Evaluate the limit of 8x cubed plus 1 by 2x plus 1 as x approaches negative half. Limit of 8x cubed plus 1 divided by 2x plus 1 as x approaches negative half. So the first instinct is to substitute minus half directly into the numerator and the denominator and to hope for a finite value. So let's put x is equal to negative half, in which case the function becomes 8 times minus 1 over 2 whole cube plus 1 whole divided by 2 times minus 1 over 2 plus 1. So this becomes 8 times minus 1 by 8 plus 1 divided by minus 1 plus 1, because the 2 and 2 get cancelled here. So the 8's get cancelled, you get minus 1 plus 1 0, and the denominator also becomes 0. Now we know this is an indeterminate form, so we cannot proceed further. So the first thing we realize is there is a common factor in the numerator and denominator which is dragging the whole function to this indeterminate form. We need to figure out that factor. So if you notice, from x is equal to minus half, we can say x plus 1 by 2 must be the common factor, or we can write 2x plus 1 by 2 is the common factor. The next step is to try to factor the numerator and the denominator in such a way so that we could cancel out this term. So the limit as x approaches negative half, we can write the numerator as 2x whole cube plus 1 cube divided by 2x plus 1. If you remember, there is a formula which relates a cube plus b cube as a plus b into a square minus ab plus b square. So we're going to use this identity and write the numerator as limit x approaching negative half a plus b, which is 2x plus 1, times a square, that is 4x square, minus ab, which means minus 2x into 1, that gives us minus 2x, plus b square, which is 1, and the denominator is 2x plus 1. Now we are hunting for this common factor, so all we need to do is divide this by 2 and divide this by 2, and we are able to cancel these terms. Or I think it is redundant to write by 2 again, so we can directly cancel these two terms. We can do so as x is not equal to minus 1 by 2. Now that these two terms which were dragging the function to the 0 by 0 form are removed, all we are left with is a clean polynomial, and we can directly substitute minus 1 by 2 into this to get the limit value. So now we put x is equal to minus 1 by 2, and then we get 4 minus 1 over 2 whole square minus 2 into minus 1 over 2 plus 1. So this becomes 4 into 1 by 4. 2's get cancelled and I get plus 1 plus 1. The 4's get cancelled and I end up with 3. So the final answer is the limit as x approaches negative half of 8x cubed plus 1 divided by 2x plus 1 is equal to 3, and that is the final answer. Alright, let us look at another limit question. Let us evaluate the limit of x square minus 2 divided by x square plus root 2x minus 4 as x approaches root 2. So let's write down the given question. Limit as x approaches root 2, x square minus 2 divided by x square plus root 2x minus 4. So as usual, hoping for the best, let's substitute root 2 into the numerator and denominator and see if we get a finite value. So put x is equal to root 2, which implies the numerator becomes root 2 squared minus 2 divided by root 2 squared plus root 2 into root 2 minus 4. So the numerator becomes, this root 2 squared is 2, so 2 minus 2 gives us 0, and the denominator root 2 squared is 2 and root 2 into root 2 is 2. So this is 2 plus 2 4 minus 4. So here also we end up with a 0 by 0, which is an indeterminate form. So this 0 by 0 form prevents us from evaluating the limit of this function. So what we need to do is try to cancel out the common factor which is leading this entire function to this indeterminate form. So looking at this, we can say that x minus root 2 is the common factor. So let's try to bring this term out from the numerator and the denominator. So if you look at the numerator, clearly we can notice that this is of the form a square minus b square. And if we rewrite it as x minus a into x plus a, one of the factors would be x minus root 2. So we rewrite this as x approaching root 2, x minus root 2 times x plus root 2. Now, one way to factorize this denominator is to actually split the middle term, or we know that x minus root 2 has to be one of the factors of this polynomial. So therefore we directly write x minus root 2. Now the other factor must be x plus 2 root 2, because minus root 2 into plus 2 root 2 gives us minus 4. And you can even check the middle term, plus 2 root 2 into x minus root 2 into x will give us plus root 2 into x. So now I can cancel these two terms and declare as x can never be equal to root 2, because x is approaching root 2. X can never be equal to root 2. So that leaves us with the expression limit x approaching root 2, x plus root 2 divided by x plus 2 root 2. Since the terms that were dragging the entire function to the indeterminate form are out of the way, we can directly substitute root 2 into the two functions. So put x is equal to root 2 implies root 2 plus root 2 divided by root 2 plus 2 root 2. Root 2 plus root 2 gives us 2 root 2. Root 2 plus 2 root 2 gives us 3 root 2. The root 2's get cancelled and you end up with 2 by 3, which is the limit value. Therefore, the limit as x approaches root 2 of x square minus 2 divided by x square plus root 2x minus 4 is equal to 2 by 3, and that is the final answer.